Welcome, fellow stargazers, to Cosmic Enigma, where we dive headfirst into the universe's most mind-bending mysteries. Today, we're tackling the ultimate cosmic question. Are we alone? Because, folks, the James Webb Space Telescope just dropped a bombshell about a distant exoplanet called K2-18b, and it's got scientists doing the happy dance, and maybe a little nervous twitch. Prepare to have your perceptions of life beyond Earth challenged. Imagine a world 120 light-years away, that's like really far, named K2-18b. This isn't your average rocky neighbor, it's a Hycean world, a cosmic oddball unlike anything in our own solar system. For ages, astronomers have been scratching their heads about these sub-Neptunes, planets bigger than Earth but smaller than Neptune. Well, K2-18b is finally spilling some serious cosmic tea. Hycean worlds are a relatively new concept in exoplanetology. They are theorized to be planets with massive hydrogen-rich atmospheres enveloping deep global oceans of liquid water. This unique combination could potentially create conditions ripe for life, even if vastly different from Earth's. K2-18b, orbiting within its star's habitable zone, presents a tantalizing candidate for such a world. The very existence of Hycean worlds challenges our preconceived notions of planetary habitability. We often search for Earth-like planets, but the universe might harbor life in forms and environments we're only just beginning to comprehend. K2-18b offers a glimpse into this broader spectrum of possibilities, pushing the boundaries of our astrobiological imagination. And who's our cosmic detective? None other than the incredible James Webb Space Telescope. This super-sleuth of the skies peered right into K2-18b's hydrogen-rich atmosphere. Think of it like Webb reading a cosmic barcode, analyzing the light that passes through the planet's atmosphere as it transits its star. Each element and molecule leaves a unique spectral fingerprint. Webb's advanced instruments, particularly its near-infrared spectrograph, ANIR spec, and mid-infrared instrument, MIRI, are revolutionary. They allow us to detect the subtle absorption lines of various gases, revealing the chemical composition of distant exoplanet atmospheres. This capability is paramount in the search for biosignatures, chemical indicators of life. What did Webb find in K2-18b's atmosphere? A whole lot of carbon-based party gas, methane and carbon dioxide. This is huge because it strongly suggests K2-18b is indeed a Hycean world, potentially rocking a massive liquid water ocean beneath that gassy blanket. The presence of these molecules aligns perfectly with theoretical models for such planets. The detection of methane and carbon dioxide is significant for several reasons. These are fundamental building blocks for organic chemistry, and their presence indicates an active, dynamic atmosphere. Furthermore, their ratios and distribution can provide clues about the planet's internal processes and its potential for supporting a liquid water ocean. But here's where it gets really wild. Webb also sniffed out a possible chemical fingerprint of something called dimethyl sulfide, or DMS. Now, why should you care about DMS? Because on Earth, this stuff is almost exclusively made by living things, specifically those tiny marine phytoplankton chilling in our oceans. It's literally the smell of the sea, and it's got astrobiologists doing cartwheels. DMS is a fascinating molecule because its primary natural source on Earth is biological. Marine algae produce a precursor molecule, DMSP, which is then broken down into DMS. This gas then escapes into the atmosphere, playing a role in cloud formation and the global sulfur cycle. Its strong association with life on Earth makes its potential detection elsewhere incredibly exciting. The implications of a DMS detection on K2-18b are profound. If confirmed, it would be the first potential biosignature detected on an exoplanet, a monumental leap in our understanding of life's prevalence in the cosmos. It would suggest not just the possibility of life, but potentially a thriving, active ecosystem within K2-18b's hypothetical ocean. Imagine vast alien oceans teeming with microscopic life, much like Earth's early oceans. These organisms, perhaps unlike anything we've ever conceived, could be producing DMS as a metabolic byproduct. This thought alone ignites the imagination, painting a vivid picture of a living world far beyond our solar system. Hold your horses, though, before you pack your bags for K2-18b. While the potential DMS signal is thousands of times stronger than anything we'd find on Earth, talk about a cosmic shout-out. Scientists are also being super-duper cautious. Why? Because while DMS is a party animal for life on Earth, we can't totally rule out some weird, non-biological cosmic chemistry cooking it up on K2-18b. As one expert wisely put it, DMS can be synthesized by cosmic chemistry without any biological process. It's not a life-only molecule. Yet, for instance, certain geological processes or high-energy atmospheric reactions could theoretically produce DMS, though these pathways are less understood in exoplanetary contexts. The scientific community demands rigorous proof. Plus, DMS is pretty fragile. Sunlight zaps it easily. So, for such a strong signal, you'd need a ton of it being produced constantly. That implies not just life, but a whole bustling alien ecosystem. But hey, extraordinary claims need extraordinary evidence, and we're still gathering clues. This is the essence of scientific discovery: excitement tempered by skepticism. The fragility of DMS means that if it's present in such high concentrations, there must be a continuous, robust source. This strengthens the biological hypothesis, as life is incredibly efficient at continuous production. However, scientists must exhaust all non-biological explanations before concluding life is the cause. This meticulous process is fundamental to astrobiology. K2-18b isn't Earth 2.0 either. It's a giant, icy mystery box, even with that potential ocean. Its larger size and different atmospheric composition mean that any life there would likely be very different from Earth life. We must avoid anthropocentric biases when searching for extraterrestrial organisms. This K2-18b discovery perfectly illustrates the scientific method in action. An initial observation, Webb's data, leads to a hypothesis: DMS presence, potential biosignature. This hypothesis then requires further testing, more observations, and independent verification. It's a journey of incremental knowledge, not a single definitive pronouncement. The scientific community's cautious optimism is a testament to its integrity. While the allure of alien life is immense, the pursuit of truth demands rigorous scrutiny. Every potential biosignature must be thoroughly investigated for false positives, ensuring that any eventual claim of life is built on an unshakable foundation of evidence. This process involves not only more observations from Webb, but also theoretical modeling and laboratory experiments. Scientists will simulate K2-18b's atmospheric conditions to see if non-biological pathways for DMS production are plausible. This multifaceted approach is crucial for validating such a groundbreaking discovery. The search for biosignatures is inherently challenging. We are looking for subtle chemical imbalances or patterns that are difficult to explain by geology or atmospheric physics alone. It requires pushing the boundaries of our observational capabilities and our understanding of planetary science. So, what's next in this cosmic detective story? Webb's initial peak was just the appetizer. More observations are on the way, and scientists will be poring over every single photon, looking for those definitive answers. They will aim to confirm the DMS signal, rule out other explanations, and search for additional biosignatures. Future observations will involve longer integration times, allowing for more precise measurements and the detection of fainter signals. Scientists will also use different Webb instruments to cross-verify the findings, building a robust dataset. This iterative process is key to moving from a potential detection to a confirmed one. The scientific community is already buzzing with proposals for follow-up studies. This includes not only more Webb time, but also theoretical work to better understand Hycean world chemistry and habitability. Every new piece of data will contribute to a more complete picture of K2-18b. Future telescopes, like the super cool Habitable Worlds Observatory, still in the planning stages, so stay tuned for a few decades, will be crucial. These next-generation observatories are designed specifically to characterize exoplanet atmospheres in unprecedented detail, potentially even imaging exoplanets directly. Missions like the proposed Habitable Worlds Observatory, or LUVOIR, Large Ultraviolet Optical Infrared Surveyor, would have the capability to search for a wider range of biosignatures, including oxygen, ozone, and other complex organic molecules. They represent the next frontier in our quest to find life beyond Earth. The search for alien life is humanity's grandest adventure, and K2-18b, with its unique Hycean vibes and tantalizing atmospheric hints, is now front and center in this epic quest. Whether it's teeming with alien microbes or just a fascinating world with funky chemistry, every discovery brings us closer to understanding our place in this vast, wondrous universe. This journey is not just about finding life, it's about understanding the diversity of planets, the limits of habitability, and the fundamental processes that govern the cosmos. K2-18b is a stepping stone, a beacon guiding us toward a deeper comprehension of our cosmic neighborhood. Don't miss out on the latest cosmic revelations. If you're as fascinated by the universe as we are, smash that like button, subscribe to Cosmic Enigma for more deep space discoveries, and let us know in the comments. Do you think there's life on K2-18b? Share your theories, ask your questions, and become part of this incredible scientific journey. Keep looking up, space cadets!